Okay, folks, I know that was a lot of steps, but this is where I want us to focus on regulation of this pathway. I have a picture of the simplified pathway here on the right, and this is kind of how I want it to be in our brains. You can see most enzymes have been removed except for the important rate determining steps. So the important flux controlling step is the one happening, the one happening right here. The first step is also rate determining, but we're really seeing tighter regulation of flux at step 2, which is performed by amidophosphorybosyl transferase. It has a number of allosteric sites that regulate this enzyme. Since the pathway is producing both, if I go back one slide, here we go, AMP and GMP, you can see that here at the bottom, the final products. You can see why it might make sense that these molecules are inhibitors. Let's clean that up. If the point of this pathway is eventually to make these two purines, feedback inhibition, where this downstream product comes back to inhibit an earlier enzyme, makes a lot of sense. If we've made enough of these, we shouldn't be making any more. That is a waste of energy, right? And these allosteric sites will bind ATP, ADP, or AMP, so it doesn't matter how many phosphates there are for AMP. Similarly, for the guanine, it can either be GTP, GDP, or GMP. If we have enough of that nucleotide, no matter how many phosphates there are, we don't need to make more. Then, we have activation of this enzyme as well. And this is allosteric activation by the substrate of the enzyme. If we have a lot of this first metabolite, folks, that can be an indication that we need to convert this metabolite onwards to its final product. Recall also, though, that PRPP is used in a variety of other metabolic pathways. So there is kind of a second level of regulation, because when we're thinking about this pathway where we're making both AMP and GMP, we might want to make sure that the levels of those two things are equally balanced between themselves, because generally we're going to need about the same amount of AMP as we will need GMP to synthesize, for example, new DNA. So the secondary pathways, if I go back to that, I know I'm jumping back and forth between slides a lot here, folks. That kind of secondary branch point pathway also needs to be regulated. So you can see how AMP, for example, will inhibit its own production, and how GMP will inhibit its own production also at the branch point. I'll also point out that the AMP and GMP themselves, let me erase this slide just to make this more clear, require the use of GTP and ATP. So AMP, let's start here, its branch point synthesis step actually requires GTP. And opposite is true. GMP in its branch point synthetic pathway requires, where are you? Here we are, ATP. So both the feedback inhibition as well as kind of using these metabolites in the synthesis of these pathways is important to help balance the overall levels of AMP and GMP made, but also balancing them to each other. We should have about the same amount of AMP and GMP compared to each other. And that wraps up purine synthesis. Up next, pyrimidine.